Get strong.
Alright guys, this time we're going to be learning about dilations. So dilations ain't too bad. It's basically just multiplying. And if your teacher allows you to use a calculator, then I guess it should be pretty straightforward. The hardest part is going to be figuring out where the original coordinates are. If you still haven't figured that out, then you need to go practice that. And you need to figure out how to label a coordinate and how to tell me where it's at on the coordinate plane, and then write it down, multiply it by this thing called a scale factor, which is what you're going to multiply some coordinates by to be able to get the new ones, and then go graph them somewhere on the graph, and you'll see the new image that it makes. And for the purposes of this video, we're going to be doing dilations that are centered at the origin, which is at 0, 0. So everything's going to be getting expanded or shrinking from the origin. So dilations with center 0, 0. And that'll be all the problems that we're doing today. So let's go ahead and dive on in. It says find the coordinates of each point in the original figure. So find the coordinates of each point in the original figure. So here's our original figure. We need to find the coordinates. So for A, we are at 2, 4, 6, 8. So negative 8, comma 8. So negative 8, comma 8. Okay, easy enough. Letter B is at 0, 0. And letter C is at negative 8, comma negative 8. All right, negative 8, comma negative 8. And it says that we need to multiply each coordinate by blank. Well, if you read the problem, it says draw the image of triangle ABC after a dilation with center 0, 0 and a scale factor of 1/4. So this right here, multiply each coordinate by blank, we're going to put a 1/4 right there. So anytime you see where it says what are you multiplying by, you always put your scale factor right here, which is 1/4. So your scale factor is what you multiply by. Okay, so we're going to multiply each coordinate by a 1/4. So if you do that, it says find the coordinates of each point in the image. So we're going to write down our new coordinates here. So we're going to take each one of these numbers, each one, and we're going to multiply each one of them by a 1/4. And we're going to put those answers down here. And then we're going to go graph them and we'll be all done. So let's see here. Negative 8 times a 1/4 should give you negative 2. And then 8 times a 1/4 should give you positive 2. And you guys are welcome to go use a calculator and or check my math on that. But it should be negative 2, comma 2. And then anything times 0 is just 0. So if you take letter B here and you multiply a 0 by a 1/4, you're going to get 0. And then do it again, 0 times a 1/4, and you still get 0. Now we're going to do the same thing we just did for letter A with letter C. We're going to do negative 8 times a 1/4, and then we're going to do the other one, negative 8 times a 1/4. And we're going to put both of those answers down here. And when you do that, you should get negative 2 on both. Now all you got to do is just go graph this guy. So negative 2, comma 2 would be here. 0, 0 would be here. It's A prime, B prime, and then C prime is negative 2, negative 2. And if you connect these dots, they end up just like this. And you get a triangle, just like that. So if you take the original image, this really big one here, and then you do a dilation of a 1/4, which means we're going to multiply by a scale factor of a 1/4, it's going to shrink it all the way down. Okay, so if you multiply by a fractional number, or a number that is less than 1 and greater than 0, it's going to shrink. So if you want to write that down, you can. So if your scale factor is between 0 and 1, you shrink, or you get smaller. If your scale factor is greater than 1, you get bigger. Okay? So if your scale factor is between 0 and 1, you get smaller. And if your scale factor is greater than 1, you're going to get bigger. And you'll see that as we go through these problems down below. It says, in number 2, it says triangle RST has vertices, which just means coordinate points. Okay, so vertices is just telling you that you have coordinate points located at certain spots. You got R is at 0, 0, S is at 6, 3, and T is at 3, negative 3. It says, is the triangle R prime, S prime, T prime is the image of triangle RST after a dilation centered at 0, 0 and a scale factor of 1/3. What are the coordinate points of S prime? So all we need to be focused on this entire problem is S, and then we are going to focus on S, and we're going to do a scale factor, which means we're going to multiply each of those two coordinates by a factor of 1/3, because it's only asking us for the coordinates of S prime. So we don't really need to worry about all the other ones because we're only looking for S prime. That's only one. So if we look at S, which is located at 6, 3, we would need to multiply both of those coordinates, 6 and 3, by 1/3. So if you multiply 6 and 3 by 1/3, you get 2, 1. And you can use a calculator to figure that out if you need to. You would do 6 times 1/3, and your answer will be 2. And then you can do 3 times 1/3, and it will give you 1. So your new coordinates are 2, 1. And, well, you're all done. All right, number 3 says, this time you have a rectangle. QUAD has coordinates 4, 5, 4, 10, 11, 10, and 11, 5. The new rectangle is the image of the old one after a dilation with centered at 0, 0. So remember, if you recall, I said all the problems we're going to do are going to be centered at 0, 0, and the scale factor of 5. So this time you have one that is a scale factor that is greater than 1. This time we have a 5. So our picture is definitely going to get bigger. And it says, what is the length of the segment Q prime, U prime? So this time we're only looking at Q and U. So let's go highlight those and kind of understand what the distance is between those two guys. So here's Q and U. And if you guys look real closely at those two, Q is at 4, 5, and then U is at 4, 10. So let's actually use this graph right below it, which obviously I know this one goes with 4. However, we are just going to use 3 and kind of chart it down here on this graph here. So we're at 4, 5 for Q, and then U is at 4, 10. So ignore the other lines that are on here. We're just trying to use this as a reference here. Okay, so we're trying to figure out this distance here. That distance is how many blocks it takes up. So let's look at that. We have 1, 2, 3, 4, 5. So the distance is 5. Okay, and it also says that we are going to have a scale factor of 5. And that means we're going to multiply that distance by 5. So if the distance is already 5, so the length of segment QU currently is 5. Now we're going to do a scale factor of 5, which means we need to multiply this guy by 5, and we get 25. Okay. So the length of the new segment, so length of segment Q prime U prime is 25. Because we multiplied the original segment by the scale factor of 5, and we got 25 as our final answer. So if we were to go times this length by 5, we would end up going all the way up to 25. And it would be ginormous. You couldn't even fit it on a graph. So that's why I went and graphed the original, multiplied it by the scale factor, and then got the new length of the segment. So not too bad. Go ahead and erase this so we can work on the next problem. All right. Number 4. The graph shows you got a triangle QJL and a triangle Q prime J prime L prime and its image after a dilation. So it says, is the dilation an enlargement or a reduction? And explain. So reduction just means that it gets smaller. And then an enlargement means it gets bigger. So let's look at the original coordinates. The original coordinate of K is right here. And then it looks like it actually gets bigger and goes up here to K prime. So if it gets bigger, then that would be an enlargement. Definitely got bigger. Okay, definitely got bigger. And then it says explain as to why. Well, I would argue because triangle KJL is smaller than triangle K prime, J prime, L prime. That's why. And then it says find the scale factor of the dilation. So now we have to figure out what the scale factor is. Oh my goodness. All right, so all we got to do is pick a coordinate. J would probably wouldn't make too much sense because it stays at 0, 0. What we would probably do is we can either pick K or we can pick L. It doesn't really matter, but we got to figure out how do we go from K to K prime, or you can do L to L prime. It does not matter, but you got to pick one. So for this problem, let's just look at L, and we're going to see how we can get to L prime. And really what you could do is just divide the two numbers, the new one divided by the original, and then you can actually get what the difference was. Like if you divide it, then you would actually know what you multiplied the original by to get to the new one. A little complicated, I know. So let's look at L. L is located at 12, 0, and L prime is located at 15, 0. So what number did they multiply by to go from 12 to 15? A little difficult to figure that out. So what you could do is you could take 15 and divide it by 12. And if you do 15 divided by 12, and you can do that in a calculator, you should get 1.25, or technically that would be 5/4. However you want to look at that, you could either say 1 1/4 or 5/4. So if you think about your scale factor, that's what it would be, because that's what you would multiply 12 by in order to get to 15. And that's what scale factor is. You take the scale factor and you multiply it by the original coordinate to get to the new coordinate. So if you take 12 and you multiply it by 1.25, you get 15. And you can go to the calculator, double check that. So if you do 12 times 1.25, you literally get 15. And that's how you could figure out what the scale factor is. So for this one, this right here is the scale factor. and you're all done. I'll go ahead and stop it there. I think after about 4 problems, I think you guys should be able to manage this. I guess the key point here to remember is this information down here. So try not to forget this down here. Your scale factor is between 0 and 1, you get smaller. And if your scale factor is greater than 1, you're going to get bigger. Hence the words enlargement and what was the other one they used? Reduction. Okay. I hope you found this video useful. If you want to, you can go ahead and like, comment, do whatever you want. Dislike it is fine. It's up to you. Anyways, I hope you all enjoyed the video, and I'll catch you guys in the next one.